Hello, how's everybody doing today? So for today, what we've got for you is another demonstration of a combustion reaction. And so as everybody remembers, the three things you need for a combustion reaction is the fuel source. And for today, what we have is a balloon of hydrogen gas, okay? And then our oxidizer, our standard oxidizer we're going to use for a lot of the demos is oxygen. So we have oxygen, and that's here in our can, right? And obviously, if we have a contained reaction, a contained combustion reaction, then it potentially can be harnessed to create movement. And so that's what we're going to do today. Obviously, we have the hydrogen we're going to move in here with the oxygen, and then that's a contained reaction, and then we have our top here, which is going to cause the Pringle can to shoot up in the air, right? So a contained combustion reaction, and we utilize that to do work, right? And so again, our combustion reaction, we need the fuel source, we need the oxidizer, and then the last thing is, oh yes, our source of fire, okay? And so first, before I do anything else, apply the fire or anything, I've got to move it in there. So obviously I have this stoppered, and this is going to be slightly challenging. Hopefully I can do this without. I'm going to do it this way. Make it easier on me. Okay. So again, here we go. Now I'm transferring all of the hydrogen. Perfect. Now all the hydrogen is in there, right? And then here is my initial source of energy for this. Okay. Everybody ready? Oh. Okay. That's weird. So as we're waiting for this, because it should go, I don't know what's going on right now, but as we're waiting, what do we need again for a combustion reaction to take place? We need the fuel source, the oxidizer, and the source of heat, right? And so what happened there? Why did it take so long for the reaction to happen? Well, another thing that we talked about is stoichiometry, right? Proper stoichiometric relationships between the oxidizer and the fuel source, okay? So initially what happened, what did I do? Well, the balloon was about the same size as the Pringles can, maybe a little bit bigger, right? And so when I did that, I fully filled this space with the hydrogen, right? And so when I fully filled this space with the hydrogen, was there any oxidizers left in there? Well, not really, okay? But when I initially lit the hydrogen, there was enough oxygen in the surrounding environment for it to keep that fire going. Well, as that was happening, as the hydrogen was moving out of that vessel, what was coming in through the bottom, through this hole? The oxidizer, the oxygen was, right? So again, that stoichiometric relationship between the oxidizer and the hydrogen, the fuel source, is very important, right? So as the hydrogen was coming out here, and then you saw the fire, you may have saw the fire burning up here, as the hydrogen was leaving this vessel, the oxygen in the environment was keeping that fire lit. And when enough oxygen moved up in there and mixed with that hydrogen, that's when the stoichiometric relationship was good enough for the combustion reaction to fully go. And again, all that hydrogen was used up immediately. And again, we utilized that contained combustion reaction to do work, to remove that top and then shoot the Pringles can up in the air. And so that's what happened, right? And so again, we looked at combustion reaction, what we need for a combustion reaction, and we also looked at the proper stoichiometric relationship, which again is what's really important. So again, as you're looking at stoichiometry, that's again what is another important concept for what we looked at today. So again, thank you much for your time, and hope you have a great day, and good luck in chemistry.